Assalamualaikum warahmatullahi wabarakatuh. I'm ILHAMENA binti RAMZI and my other member Aisyah binti Nazri and NURUL SYAFIQAH binti TANDA. Today we will present our video presentation, which is the topic of this presentation is application of differentiation.
What is differentiation? Differentiation is the process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulations, using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions.
Why do we use differentiation? It allows us to find rate of changes. For example, it allows us to find acceleration, which is the rate of change of velocity with respect to time. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve.
Next is step to answer this question. Firstly, we need to draw a diagram related to the problem. And number 2, specify in mathematical for the rate of change and record all the information given. And number 3, find an equation involved. Number 4, differentiate with respect to time t, which is t. And lastly is state the final answer in correct form and unit.
Problem statement: the rate of change. Question 1. A cube is being increased in size such that the length of each edge is increasing at 0.1 centimeters per second. Find the rate at which A. the surface area, B. the volume of the cube is increasing when the side length is 10 centimeters. For this question, we're gonna use chain rule method. For question 1a, we have been asked to find the rate at the surface area. First, we're gonna write dx over dt that will be equals to 0.1, and then write down the formula. dA over dt equals to dA over dx multiply with dx over dt. So the surface area of the cube is 6x squared. Then we're gonna differentiate the surface area over dx. That's gonna be dA over dx equals to 12x. Now we're gonna find the rate of change of surface area with respect to time when the side length is 10 centimeters. Okay, now back for the calculation. dA over dx is gonna be 12x multiplied by dx over dt, which is 0.1. Now we're gonna replace x with 10, and we have 12 times 10, it's gonna be 120. Then times to 0.1, and the last answer it's gonna be 12 centimeters square per second.
Okay, for the next question, which is question B. The question is a cube is being increased in size such that the length of each edge is increasing at 0.1 cm per second. Okay, then find the rate at which the volume of the cube is increasing when the side length is 10 centimeters. We can consider a whole cube as a x and the other one is 6x squared. The v is x cubed while the dv over dx is a 3x squared after differentiating. So we can use also chain rule steps. The dv over dt equals to dv over dx times dx over dt and equals to 3x squared times 0.1. So dv over dt with respect to 10 equals to 3 times 10 squared times 0.1. And just calculate as usual. Just use your calculator. Then the answer is 30 centimeter cubes per second.
Question number 3. The question is, an empty container is filled with liquid. The height of the liquid in the container is x centimeter and its volume is v centimeter, where v equal to 1 over 2 pi x 5 minus x. If necessary, at the rate of 0.05 cm per second, find the rate of change in volume when x equal to 2 cm. Dx over dt that given in the question is 0.05 cm per second, and the volume of container that given in the question is 1 over 2 pi x 5 minus x, and we need to expand equal to 5 over 2 pi x minus 1 over 2 pi x square. So next we need to find dv over dx. dv over dt equal to dv over dx times 2 dx over dt. dv over dx equal to 5 over 2 pi x minus pi x. dv over dt equal to 0.05 times 2 5 over 2 pi x minus 2 pi, and the answer is 1 over 40 pi.
The conclusion of this video is differentiation is a process of finding a function that outputs the rate of change of one variable with the respect to another variable. It is also one of the most reusable calculation that we need in our work. Differentiation will enable us to address all kinds of issues in this wide world. If two related quantities are changing over time, the rates at which the quantities change are related, so we can consider it as a related rates problem. In engineering world, calculus is needed for derivation of the basic equation of fluid mechanics. For example, to obtain the results, all hydraulic analysis programs that assist in designing storm, drain, and open channel system use calculus numerical methods.
While doing this video, we refer some websites to help us about application of differentiation, which is some references are from YouTube and Google.